Welcome, welcome, my lovely students. We are now looking at what is going to be our last topic for the 1311 part of the course. I've got 3 different days worth of lecture material, but it's all related to solving systems of equations. So I'm probably just going to record it all today and tomorrow, post it all in one go. So you do not need to finish this homework that quickly. In fact, I am probably going to move the due dates on all the assignments soon. And that is so once I move the due dates into the future, anything that you've done work on that it was still showing a 0, you'll now have a grade. There's not an easy way to do this. There's lots of behind the scenes crap, but basically I'm going to move the due dates till after the final. You should finish it by the final. But our final isn't until December, so you have time to finish all of my stuff. Make sure you stay on top of college algebra. And as always, whatever questions you may have, please come visit me. Even if it's questions about your college algebra test, please come visit. All right, so a system of linear equations is 2 or more linear equations make up a system. Typically, we're only going to see 2 right now. A solution to a system of equations is an ordered pair that is a solution to each individual equation, meaning it works in both equations. It has to be both. If we're going to look at this graphically, a point that works on both lines is a point that is on both lines. So if the same point is on both lines, that means they're crossing at the point. One of the ways to write this is as an ordered pair, so an xy point. And then because that is a solution, we can write it as a solution set with the set brackets around it. Honestly, most professors don't care about that, but feel free to ask your college algebra instructor. Honestly, most of the time we just write the ordered pair. And I've even taken x equals y equals. So first one, just because there'll probably be a bit of it on your homework, determine if the ordered pair is a solution to the system. Well, if it's a solution, it has to work, meaning it has to give us a true statement. So we are literally just going to take the numbers, plug them in, see what we get. So we are first verifying, we're seeing if the point 2, -4 is a solution to this system, meaning it's going to work for both equations. So for our first equation, that is 2 for the x, -4 for the y. We're going to see if that's true. And 2 for the x and -4 for the y. I'm going to see if that's true. Now you can quite literally type it exactly how I wrote it here on the calculator, crunch, poof, answer. Just without the equals, whatever the number is. You're seeing if the left side calculates to the right side. So here, 3 times 2 is 6, minus -4 becomes +4, and 6 plus 4 is indeed 10. So the point 2, -4 is on the first line. Then over here, the parentheses are just there as a safety precaution, but it's really just the number 2. And then 1/4 of -4, well, 4 goes into 4 once, positive times negative is negative. So this is 2 plus -1, or just 2 minus 1, which is indeed 1. So that tells us that A is a solution. And I was a chem major for a while, so SOLN is the abbreviation for solution. All right, now we're going to see if this crazy point works. Now, a kind of nice tip for doing your homework faster, they almost always work in the first equation. So to say it's not a solution, it only has to fail in one of them. So you can actually skip to the second equation and see if it'll work in that. And if it doesn't, then you're done. If it does, go back and check if it works in the first, and don't be surprised when it does. All right, so here, just like the 2, the 1/3 is just in parentheses as a safety. So we have 1/3 plus 1/4 of -9. It's -9/4. So 1/3 plus -9/4. So -9/4 is -2 1/4. And if I add a third to that, it's still going to be a big negative number. And there is no way it is going to be +1. I don't even really care what the number is. It's just not going to be that. So not a solution. All right. So a little bit of that just to get your brain working on this idea of if I have a couple of equations, then if they're in two variables linear, I can solve for y and graph them. And if I graph them, they're going to cross somewhere, usually. Now, why did I say usually? All right, well, I got my two lines. So, haha, they cross, they cross, they cross, they cross. Lots of ways to do the two lines. But what if they don't cross? Ooh, what do we call these kind of lines? Yes, parallel. Yes, I'm being crazy. I don't care. So parallel lines never intersect. So there is no point that works on both equations. So there is no solution. Now, what if this one works better with props? I have a line and a line. Yeah. There. So we know we drew the orange line and then there was the green line right on top of it. So how many points of intersection are there with these lines? Definitely at least one, yes. More than one? Yes. Now, I want you to think, weird question. Is there any way to draw two straight lines in such a way that they only intersect in 2 points? Not more than 2, just exactly 2. So like 2 points here, either end of this marker as a line segment. The only way to connect those 2 points is with the straight line I see right here. Any other line won't be straight if it goes through those 2 points and doesn't also go over all the others. Because when we ask this kind of question, we're not thinking about wormholes or fourth dimensionally. So if 2 lines intersect in more than 1 point, they're the same line. And if they're the same line, they line up everywhere. Everywhere means there's an infinite number of them. But they do follow a particular pattern. So it's not all the points. It's just all the points on that line. So let's scroll here and take a look. So this is one of the lovely graphics from the book. And this is classified by how many solutions there are. So most of the time you are going to see one solution. And that one solution is that one single point. So it is unique to the system. Now, if we have parallel lines, they never intersect. And then they've got some examples here with the equations. And what you're going to see with parallel lines is the system has no solution, but it means the slopes of the two lines are equal. So if we solved for y, the number in front of x is going to be the same. But the y-intercept will be different. So here, they both have a slope of -1, but our y-intercepts are not the same. So these are indeed parallel, but two distinct lines. As opposed to over here, you notice it's a purple line. It's purple because it's technically the red, that pink, and that blue on top of each other. Now, initially, it may not look like they're the same line because it's like, well, it's not exactly the same. No, but check out, how would I go from the first equation to the second equation? X versus 2x, -y versus -2y, -1 versus -2. Yes, they literally took the first equation, multiplied by 2. There's the second equation. So if I solved these for y, they would look exactly the same. What we're going to see is using our other solution methods, we're going to work through some algebra and arrive at an odd answer. And we just have to learn how to interpret those answers. All right. And sometimes the book likes to use fancy words. Inconsistent versus dependent. So to me, inconsistent is a more negative word. It's a bad thing. So that goes with no solution. Whereas dependent, one thing depends on another. One of the meanings of dependent, or the word depend, is actually hang from. It's kind of where pendant, like on a necklace, comes from. So if one line is hanging on the other line, then they're the same line. But for me, it's not the negative word, so it's the other case, infinitely many, if you have to remember it. But I think you guys are going to get formula sheets, so you could just write the words down. I personally don't like testing those words, but I don't always get to write every single test question. Okay. So one of the methods that you can solve these is by graphing. The problem is when you graph, you are getting an approximation. Even with computer graphs, technically the answer is an approximation. Now, if the answer you get is a whole number point, you could easily check to see if it's the solution for both of them. And for the questions you're going to get from Alex, they're going to be pretty points. They may not always be whole numbers, but they'll be like small denominator fractions, like halves or fourths, maybe thirds, maybe fifths. But it's not going to be anything super crazy like pi or square root of 2. So you can use the graphing calculator, and there's an intersection function where you can figure it out. There's also an intersection function on the Alex calculator. I would recommend figuring it out how to do it on your own calculator if that's a method you want to use, because you're not going to have the Alex calculator when you're taking the other test or the final. Okay, so there are technically three algebraic ways to solve systems of equations. So the first one is the substitution method. This is, in my brain, it's kind of the default method because it's the method most people, if you just throw two equations at them and say, figure out where these two intersect, this is probably the one they'll arrive at, assuming they don't doggedly stick with guess and check. Technically, guess and check works, it's just tedious. And it can take forever. Substitution, you work through the process, answer, done. We're also going to see what's called the addition method. That's where you line up the two equations, set them up so some of the variables cancel, and then you add the two equations together, which is a weird thing that most people don't normally think of unless it's shown to them. And then the other method, which we won't learn until the very end of the semester, is matrices. If you already know how to use matrices, by all means, use the matrices to solve. Unless they forcibly make me, I don't like asking questions where I force you to use one method over another. There are certainly questions where one method is better than another. And, some questions you look at is already set up for the addition method, just do the addition method. Other questions, though, it's already solved for one variable. The other one, you can plug it right in, easy to go. All right, so let's talk about this substitution method. It is exactly what it sounds like. Take one equation, get one of the variables by itself, take that result you got that's equivalent to the variable by itself and shove it in the other equation and solve. Once we shove it in, we are replacing one of the variables with an expression that's in terms of the other variable. So then we will just have that other variable in the equation, and we can solve using our normal equation solving skills. So if you look here at our lovely example, we've got 3x plus 4y equals 5, and x minus 3y equals 6. So that setup, where we have the x and the y on one side, the number part on the other, this is often called standard form. This is actually a perfect setup to do a matrix. That's exactly how you want to see the equations for that. But I don't get to show you guys that till the end of the semester. Or if you come by office hours and ask. All right. But that x there, technically we could solve for any of them, But if I wanted to solve for 3y to get y by itself, I'd eventually have to divide by -3. I don't want to divide by -3. I'm lazy. That x doesn't have a visible number in front of it. It's got an invisible 1. So I don't have to divide by 1 because I'd get the same thing. So we're going to get that x by itself. I do that by adding 3y to both sides of the equation. And technically, you could think of it as we're adding the equation 3y equals 3y, which is a very silly equation, but it is true. I'm adding that to both sides of my equation. So now I know that x is the same as 3y plus 6 or 6 plus 3y. It doesn't matter what order you write it in since it's addition. And it won't matter for substituting. So we have solved the second equation and gotten x by itself. So this tells us x is the same as 3y plus 6. So I'm going to take my other equation here, and then in place of the x, I will fill in what it is the same as. But first, I'm just going to write the equation. Make use of the pretty colors. So I took what x was the same as, shoved it in there. Now look at this equation, brand new eyes. Y's, y's, and numbers. I can solve this for y. I may not want to, but I can. So 3 on the outside means we have to distribute that 3 through both terms. This is why you always substitute with parentheses, because if you didn't put the parentheses, you'd probably remember to do 3 times 3y, but you might forget to do it to the 6, and there goes the rest of the problem. So 9y plus 18 plus 4y equals 5. All right, so the 9y and the 14y is going to give us 13y's, and at the same time, I'm also going to minus the 18. So we have 13y equals a -13, and we divide by 13. Divide by 13, we get y equals -1. I have a solution. I am done. Yes, y equals -1. And then you go type that on Alex, and Alex goes, pfft. That is only half the answer. Remember earlier I was saying a solution is an ordered pair. The first example we did was, is an ordered pair a solution? And you had to plug in both parts, the x and the y. Y equals -1 is only one part. I still need to take that and figure out what the x value is that goes with that. Now that I know y equals -1 is one of my answers, like one part of the answer, I should say, any equation I have here that has x and y in it, I can use to find the x. So I could plug in -1 into 3x plus 4y equals 5. I could plug it into x minus 3y equals 6. But if I plug it into this one down here, x equals 3y plus 6, well, it's already solved for x. So when I plug in the y, I just have to do a calculation. So 3 times -1 is -3, plus 6 is +3. All right. So the ordered pair solution, the xy point, is 3, -1. And then Alex will probably put the curly braces around the text box. So you shouldn't have to worry about doing those. And like I said, most teachers don't care if you write those for a solution that's just a single ordered pair. But it's not incorrect if you do it. Like, this is the most technically correct. All right. So that is the substitution method. Take one equation and substitute it into the other. And just shove it in. Yeah, bad hand gesture, sorry. All right. So now, take a look at this ugly mess. I have 3x equals 2y minus 11, and 6 plus 5x equals 1. All right. And I'm looking at this now, and my brain is going like, is there something wrong? There is something weird. Take a moment and see if you can see what's weird. And hopefully what you're seeing is it looks like I made a typo in the second equation. I did not. That is what the book had. That second equation only has one variable. If it only has one variable, we can solve for that variable. So that is where we're going to start. So I'm going to move the 6. 5x equals -5. Divide by 5. X equals -1. So I took one of my equations and I got a variable by itself. In this case, the stuff on the other side is just a number. I have already solved half of this. I have 1/2 of the answer. And if it was multiple choice, any answer that didn't have -1 for x, I'd cross off. Now I need to know the y number that goes with this. Well, I can't plug it back into the second equation because there's no y value to solve. There's no y variable there. So I have to plug it back into the first equation. Now, before we do that, though, I want you guys to like pause and think about, these are graphs. Like, these are lines I can draw in an xy plane. So I've solved this one for x. What the heck is x equals -1? So hopefully you remember x equals -1 is all the points that share -1 for the x, which are all vertically stacked on top of each other and run through -1 on the x-axis. So this is a vertical line. So what we're looking for is the intersection of a vertical line and some sort of diagonal line. They do cross. They only cross at one point. Just makes the solving nice and easy. Now, if it was a y equals line, it'd be horizontal. And still, it crosses in one point. We can solve it. It's just algebraically, those are easier to solve. So don't freak out if you get something like this. It's not a bad thing. It's a gift horse. All right, so we're just going to take -1 and we're going to substitute. So 3 times -1 is -3. All right, and then we add 11. So -3 plus 11, 11 minus 3 is 8. Yay, it's divisible by 2. So -1 and 4. -1 for the x, 4 for the y. Remember, your ordered pair, -1, 4 is not the same as 4, -1. The order you put the numbers in matters. If you know yourself to be the kind of person who is dysnumeric, who flip-flops the numbers, make a note to yourself to double check before you submit your answers. All right. So you may or may not have homework questions that force you to graph the lines. Those can be persnickety, but it's the figuring out how to type in graphs annoying, not the actual solving. You can always solve it algebraically and then just figure out how to graph it. Feel free to come ask me in office hours. I've dealt with all those annoyances before. I know it's a pain. Even if it's on your college algebra stuff, I know there's a couple assignments in there that you're just like, I'm going to kill the computer. Especially when it's like 10 parts and it keeps going. Feel free to stop by. I am there to ease your suffering. All right, catch you on the next one.